Oh, you know I'm pissed. For a simple answer, look up the electron shells where the orb. Honey, I've made entire videos that show the electron shells. Those electrons you see around an atom, according to the diagrams, are just one electron. So you have to understand. Whatever. Let's read all. This is a lot to read. Holy crap! But I've made longer essays, so I'll listen, I guess. Look, if you look up the diagrams of electron shells where the electrons are thought to reside, you'll see they're not generally in the simplest circular shape, spherical shapes. They don't correspond to orbits. Honey, that's because there are so many. You have to understand, an electron is going fast around an atom. How fast? Again, 2.2 kilometers? No, 2.2 thousand kilometers per second, otherwise known as 2.2 million meters per second. And what you should get from that, when you think of 2,000 kilometers, look at a map. Find the distance. Imagine that in a second. Imagine that, but orbiting a grain of rice. Then go smaller. You realize that there are 22 quintillion or electron atomic widths per second is how fast. So the width of an atom, okay, even a hydrogen atom or whatever, said to be minus 15, 10 to the minus 15, right? So you take that, you put that on top of the 2.2 million, you end up with 22 quadrillion. The number of zeros all add up to that. That's just how scaling works. So if you take that entirely super long string of electrons, which is a single electron in 1 second, and you try to wrap that around an atom, you're going to end up basically taking a few miles long of string, wrap it around, and you end up with a massive amount of circles around whatever you're wrapping it around. It's insane. Don't do this with normal string. Don't do this with razor wire. You won't be able to do it. It's so freaking much in a tiny space that it's hard to really quantify it. But if, like, the biggest ball of twine is almost to scale of an electron's orbit around an atom. Just to look up the world record ball of twine. So what you have to understand is it's going around so many times that it pushes away its own self to the side, to up, to the down. And they're all moving at the same speed, but all in their own independent directions. Or that is, the orbit is not circular, it is a slight corkscrew, so slight that it changes its direction barely, and then that is due to it running into itself and then moving to the side. And so it operates like a cloud. It is moving at the frames of approximately 5 quadrillion. Okay? 5,000 trillion frames per second, orbits per second. It's an insane number that nobody has the ability to contemplate how to really simulate it correctly. They always fall short. They always don't understand. It's an extreme number. So when you have something like that, you're going to realize it's going to look like a cloud, right? The orbital model is to think of an electron as a cloud. It's not to think of it as a cloud. It is basically a cloud. It has pushed itself around so many times that is just one electron. And it's not a cloud. It's a bunch of orbiting items that it's orbiting based on electromagnetic properties, not gravitational. But it's still in orbit because its motion is determined by its electromagnetic connection to protons, right? The cloud model is still not accurate. That's because it's not a freaking cloud. It's an individual circling so many times. If you were a person going so fast that you could orbit the Earth quadrillion times a second, you would take up the size of the entire Earth, and you'd fill it with just yourself, circling around the planet, running on water, running through the air, a few stories above yourself, with no action. Like you'd be running on the shoulders of yourself, and then you'd be running on the shoulders of themselves and themselves and themselves, a few layers up. It would be crazy. And that's just you, a singular you, moving so fast that it's, for anyone looking at it, it would be a very big blur. And you'd be distorting all of the air around you and whatever else. Let's just hope that you're not in an atmosphere, because that would suck. And the fact that you're even stating the cloud model, you don't understand even the basic fundamentals of the speed of the electron is super fast. Light is 140 something times faster. So you know it's fast, because the speed of light is crazy. Subatomic particles do not have definite position or velocity until you measure them with something, or something jostles them. No, this is a complete falsehood. They're moving at, like I said, a quadrillion times. That's not a number I made up. That's just math. A quadrillion times around an atom every second. So no matter how fast your camera is, you're going to see echoes. You're going to see individual electrons. And the thing that you're trying to reconcile is, who is the electron that's in the front of the pack? You can't find it. They all resolute, and they are all measurable with like the visual clarity of every other electron. It's not like the first electron and everyone else is a blur. Every single one of those looks like a normal electron, but it's just the echoes of one electron. Okay? Superman has nothing on electrons. Superman, like compared to scale, Superman will never be anywhere near. The Flash is not close. No one is ever in comic books as fast as an electron, so fast. Like in one of the Superman movies, he orbited the planet. He did a single doubling up on himself. That's it. He sucks. He doesn't have bunch of copies of himself orbiting a planet so fast that it literally, like, he can change the rotation of the Earth, he's still not powerful enough to be comparable to an electron to scale. He sucks in that comparison alone. Not in general, just shut up. Okay? Or they fall into a definite position, and then we're measuring. That is not that just we don't, not just that we don't know the electron's position, but fundamentally it has no actual position until something jostles it hard enough that breaks its superposition. You realize, honey, it is called the photoelectric effect. If you shoot an electron with a photon, specifically an orbiting one around an atom, it will jump up. And if your camera was fast enough, you could see which electron jumps up. No camera is fast enough to go a quadrillion, a billion frames per second. I've seen 1 billion frames per second, not a billion frames per second. Okay? That's twice the billion. It's insane. It's just not been done. The fastest camera, I literally have seen 1 billion frames per second camera. It's half the number of zeros you need in order... Wait, no, that's not right. Shut up. Oh, God, because there's always the extra 3 zeros on the end of the billion. It's not the same as 2 billions. Shush. I know. I'm just saying. That would make it 1,000,000 billion. Which is, numbers are weird, okay? 1,000 is what million should be, because it is the singulars, okay? But you have 1,000, and then you have million, which is the uno, and then billion, which is the duo. You think of it as a single and a double of the triple zeros, but it's not. It's single and double. Every one of those numbers that are scientific numbers, quote unquote, are assholes, because there's 1,000, an extra set of zeros you had to add on to every one of those numbers. So if it's septillion, that's 7, so it's 7 zeros plus another 1 set of zeros for the 1,000. It's so unintuitive. So yes, a quadrillion is 1,000,000 billion. Not 1 billion. That's quintillion. Because 2 plus 2 equals 5. Because you don't think of the 1,000 place. Because the number system is stupid. It's stupid. But you can't change what 1,000,000 is. It just is that. I wish you could. Then everything would make sense. Actual notations like that? Okay, we're just gonna imagine that you have to add a +1 triple zeros to every scientific notation ever, so that none of it makes sense. Every single one of them is off by 1. So if you're thinking about 19, nillion, whatever it is, and then you add 20, you're actually adding 21 and 20 sets of triple zeros. It's silly. Who cares? The point is, blah, 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 blah. It's not just that we don't know the electron's position, but fundamentally it has no position until something jostles it hard enough or breaks its superposition. Again, superposition is a joke. It's just a word that people have used because they don't know how to say it's in so many different positions all at the same time, but each one of those other superpositions, as you might say, I call it an echo because it's where it was in the past, an echo of its former self, not a real thing. not a superposition. It is a past self. It is a previous version of the entity. It is what it was a quadrillionth of a second ago. It used to be there. And then another quadrillionth of a second ago, it was another position, and so on. And all of these add up to make a big circle with many rings. Okay? I've seen orbital shells. I've made videos about orbital shells. If you did any research, you'd see I have a picture I love so much about orbital shells. It's in my favorites. This picture shows you electron shells. And I literally talk about this all the time. Those are echoes. Each one of those pixels is a single echo of just two electrons. Two electrons. One's on the top, one's on the bottom, and the atomic mass is in the middle. These are cross sections of the electrons. You got to understand, this is something that is represented here in a two-dimensional space. That is happening in a three-dimensional space. So there's this times pi more, or pi r squared, or whatever the hell you want to call it. It's this turned into a sphere, okay? 360 degrees more radians of this. So yes, I know about those diagrams. I understand. What you don't understand is how fast they go. The superposition of all possible positions. No, it's not possible positions. They existed. They existed, past tense. They had been done existing in those positions. Fractions of a nanosecond ago, they were in the other positions. That's not possible positions where they might be in. They have been there. They physically were there. That's not where they might be. That's where they have been. Where they did do the traveling and be there. So if you were, say, a person moving at quintillion orbits around an atom per second, you would be 1,000 times faster than an electron to begin with, and, well, maybe 200 times faster. Shut up. But you'd be going so fast that you could just move and weave through each of the electrons. And you could see that they all seem to physically exist because of persistence of vision. There's also the physical properties, the electromagnetic field of each one of them is still there. It's physically present. It's so fast that the physical phenomenon of electromagnetism hasn't had time to dissipate. It still exists there. The next thing he says is that also includes the states where the electron is nowhere near the nucleus and any longer, but it is much more likely at other positions within the electron shell we think them as occupying. No, their orbits, okay, can be, imagine if you're going around a planet and you're going so fast that you're going to hit yourself. You have to veer to the side, right? So in order to do that successfully, you would veer to the side, you would circle all the way around and create these rings of orbits that would be twisting constantly. And then you would change your other position. You might not even just go twisting, as they say, spin up and spin down, because guess what? Now you've twisted so far around, your orbit is no longer clockwise, it's counterclockwise, which makes you look spin up and spin down at the same time. But that's different moments in your history. It's the same electron being spin up and spin down in different positions with a fraction of a second difference between them. A fraction of a nanosecond, a femtosecond difference between them. Okay, what's this guy have to say? They are not orbiting electrons. They're too small. You have to think of quantum physics. Yes, magnetism. It's still an orbit around a magnetic field. There's no difference. We are taught to think of orbits because it's simple works. No, it's because of angular momentum. Is the only way that you can take something going as fast as 2.2 million meters per second into a very tiny a tenth of a nanometer is the size of an atom. Okay? 10 to the minus 15. And so if you're orbiting something that small and you're going somewhere that big, your orbit is insanely many times per second. It is an orbit. You just can't think about a regular thing that is like a slow-ass plane or a person walking around a planet, or even the simple diagrams of like one thing going slowly around a planet or whatever else and you just speed it up. It's not like speeding up footage. You're physically there in all of those positions at the same time. It's as if you were to take the orbits of the moons of Jupiter and speed those frickers up with higher gravity so much that they would physically occupy similar spaces. Now, planets don't have the ability to change their trajectory like an electron can. So, because they are so much massive and they don't have repulsion fields of electromagnetism that they are generating, which it's gonna blow your mind. Apparently, some people have the theory that electrons are made by split photons, which means a photon has structure, and you split it in half, it will swirl and turn into a electron. Its momentum turns into angular momentum. Instantaneously, it's not capable of changing that fact because of its structure. It is forcing it to curl constantly at near the speed of light to cause, if it's still going, if the fraction of if the half of a photon, which is deformed, is going at the speed of light, it would be moving at septillion orbits per second. And what it is orbiting is the electromagnetic field inside the electron that it generates from its motion. Although it's also just moving so fast that the electromagnetic field is generated anyway. The electric and other field is generated. That's a crazy thing. What are you talking about? The orbital diagram is antiquated and is known to be wrong for quite some time. However, it is quite a useful metaphor to describe some incredibly complex. Electrons exist in a cloud. Oh, you're so naive. I'm calling you naive because you're completely wrong. You just don't understand speed. The cloud is like a field of millions of times the size of the nucleus. No, the electron is so much smaller than protons and neutrons that the cloud, which is quintillion echoes of the same one electron, that it occupies a massive space comparable to the size of the nucleus. But it's not multiple, it's just one, moving crazy fast. Electrons do not proceed in an orderly fashion around the nucleus. They exist in any and every point in the field. Okay, you said something right. Every and any, but that's not correct. They exist in orbitals that, if you really looked at it, and I have looked this up, if you look at the orbitals pictures that we have found, what is the Rasputin? Why? Hmm? I'm not going to respond to the rest of these comments because I'm responding right now. Look at this. This is nonsense. I'm sorry. The problem is all of you get at most a B. I can't give you Fs because some of you are saying some things that are correct, like, oh, they exist all at the same field. No, they don't. Let me show you something. Okay, some idiot in my comments said that they exist in all positions at the same time. Look at these diagrams. What do you see? I see an electron that's going around in its normal circle, and then sometimes those orbits converge and they make super dense sections that sometimes they're moving clockwise in a north to south, and sometimes they're moving what you would maybe say clockwise in an east to west. This is clockwise east to west, north to south. This is clockwise northeast to southwest and southeast to northwest. I got that correctly. I can't believe I did that correctly. So different distributions of where the orbits and the motion do, because it's a changing orbit. It doesn't fucking work like a cloud. It works like a thing that is flowing around an atom so fast that, and it literally has to avoid itself, so it changes direction. And then sometimes those changes of direction converge into this type of thing, that type of thing, that type of thing. It's the number of electrons all bunched up together into different positions and stuff. For some reason, I don't see any difference between this and this. That's crazy. And this. They all look the same. What the fuck? What is the difference? I don't understand. Similarly, this is the same as this, right? Or it looks like it. This is interesting where that can happen. And it's all these different orbits that are, again, different fraction of time. Okay. Now let's see if they're correct about anything in this Wikipedia. Orbital was months. So a hydrogen, this is just a hydrogen. It just has one electron, by the way. This is real. This is physically what happens. The thing is, these changes happen probably a nanosecond away from each other. This is all the different phases, and the different phases of these and how it changes its orbit is like pretend you're going around in circles, and then you're going around in circles, and then you're going around in circles, and then in circles, and then in circles. Imagine that kind of motion. That's what you're doing in three-dimensional space, avoiding each other constantly. You have to understand, this is the thing. I have to save this and put this into my favorites, so it's another one of those diagrams that I can just go back to. I don't want to have to look it up. Okay, these are all the same orbitals, right? So again, you can't just keep saying stuff like this. You can't. Because you have to grasp how fast. Hold on. How fast is it going? How fast did they say it's going? Blah 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 blah. Do they say how fast it's going? Because that's important. Orbit electron properties. Double slit experiment. Shut the hell up. Diffraction of electrons. No. Two slit diffraction of electrons? No. What's happening is the electromagnetic field is going through the double slit, making the interference pattern. The electron itself is a little ball that goes through wherever it might lay, and that's it. It doesn't have wave-particle duality. There is the electromagnetic field doing the waviness, and the particle does the particleness. You can't combine them. They are two separate entities. The electromagnetic field is what connects the electrons to the protons in an atom. It's what keeps them apart as well. Okay? You cannot be saying these things, but you are, and it's stupid, it's dogma, and I'm tired of it. It has to be properly understood. It has to be properly explained. Let's just go and look up the speed of an electron, because how the fuck do I even find that shit? Just electron. Can you say that? Can you say the speed, please? Lifetime is so many years. That fuck, I don't know what that means. Discovered, analyzed, particle position generators, blah 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 blah. Charge, moment. Can you please just, what the fuck? Why can't I see like this? Shut up. Now, it's this kind of bullshit that gives me the number of 2,200 kilometers per second, approximately. In a hydrogen atom, the electron speed is, so that even just in the orbit of of a hydrogen atom, it's moving at 2.2 million meters per second. Okay? And I was close. I said it was 1 to the 140th the speed of light. It was 137. That's close. I do some back in the napkins and I'm still right. Close enough. The point is, yeah, 10 to the 6th meters per second, right? In other words, million. You got 10 to the 3, that's 1,000. 10 to the 6, that's million. 2.2 million meters per second. Okay? You translate that into the 10 to the 15, you end up with 6 plus 15 equals 10 to the 21, right? What number goes into 21? 7. It's ironically 7 times 3. It's a perfect number. So how fast is that? Well, take 7. Forget about the first 3 because of the 1,000th place. And you end up with... Wait, is it 2.2 sextillion atomic width per second? Not even quadrillion or quintillion, but... What? That's crazy. Sorry, I have to look up. Wow, you're very fucking smart. Oh, it's sextillion. Holy shit. Did I do something wrong? Size of atom. Okay, 10 to the 10th. That's where I went wrong. So it's 5 plus 10. Or no, it's 6 plus 10, so 16. So number for ten to 16th. Quadrillion. I was right. Quadrillion. This is why I have these numbers in my head. Quadrillion. It's why I say 22 quadrillion. Because it's 10 quadrillion. Is 10 to the 16th. I just added the powers together of the 10 and the 6. Right? It's the 6 is the meters, and then you go to the minus meters in the atomic width. So it's 22 quadrillion atomic width per second. This is a real number made by actual math. Okay, based off of the numbers I've already explained. Okay. The size of an atom, the speed of an electron in an orbit of an atom, and you end up realizing that that's a lot of orbits per second. So when you try to take a picture of it, you try to simulate it, you're going to end up seeing a cross section. If you took a proper three-dimensional picture of electrons going around an atom and how they fluctuate, you would see the orbits change. But you would have to be 1 trillion frames per second in order to get close to seeing how the orbits change. And imagine you have to do 1,000 frames of anything, and you go at 32 frames per second. That's a movie. Okay, it's about 32 frames per second. That's about 31 seconds. If you're going at trillion frames per second, you will have half a minute of footage of this electron just whizzing around, changing shape as its orbit changes. But you would have to be going at 1,000,000,000,000 frames per second to see that. You'd have to be using something that doesn't interfere with the positioning of the electron itself, like photons or whatever else. You'd have to use something like X-rays or something. I don't know. Here's the thing. You could use certain frequencies of light, or again, I love to think that if you used spectrum light, which is a combination of all sorts of different spectrums separated and sent simultaneously, the differences that happen to each of those lights, but also spectrum light is going to like bombard all the electrons orbit bits, and it's just going to be pushed so hard you might shoot it straight off the hydrogen. It's hard to do this without messing around with things. So what you need is something that doesn't interfere with the electromagnetic field and something that can go super fast. Neutrons. So if you shoot neutrons at it, it might have a chance of bumping it with its momentum pushing it, but it won't do the same thing as the photoelectric effect. So neutrons might be able to be used as a form of seeing electrons. Is that crazy? I don't know. I don't care. I genuinely don't care. You can't keep talking like this. It's not a goddamn fuzzy cloud. It looks like a fuzzy cloud. Imagine if you had a person driving a car in a circle so many times per second that it looks like this. And then you slow down the footage so that you can see the individual car. The problem is that's not what happens with electrons. Electrons are going around so fast, their separate individual echoes still persist because all of the physical properties haven't had a chance to stop influencing nature, right? All of the electromagnetic properties, the physical way that it might bounce light, and all of that. That's why I love that picture so damn much. This picture is amazing. I absolutely love this picture. Especially in the white mode. In dark, you can hardly see it. In light, you can see like the individual electrons in this whole thing. How fuzzy they are. Each of those little dots are supposed to be an echo of an electron. Okay, it's very freaking cool. So you can't tell me they don't orbit. You're just not thinking how... I mean, just a general idea of, 1, their speed. 2, conservation of momentum says it has to go in a circular, mostly circular orbit because it cannot, it has no ability to simply go, like it could be an offset egg-shaped orbit. A lot of orbits are egg-shaped, but again, when you multiply it by quadrillion, it's doing that every second. It's going to be in all sorts of different positions at any given second. Instance of those seconds. Instance of nanoseconds. So yeah, this is just one comment. I didn't want to just stick to this. I mean, we're a comments video. We're not a science video. What are we? So nice rhyme. I don't know if you understand this, but I think rhyme has an H in it. I don't understand why you said Rasputin. I'll just include the audio next time. Everyone loves the bubble. And the drink, don't drink it all. Sprite. Strite? I said Sprite. He said Strite. Who cares? Ha ha ha. Oh, something new. Grape. Medicine. It doesn't really taste like medicine. And I mistyped there. Is that going to change how his tag works? I don't know. Maybe. Maybe I should edit that. There you go. You're properly tagged. Yes. The school memories. Chocolate milk. Where were you? I was at Dungeons and Dragons. Nice crunch. Yeah, the spicy chips with the friends of Dungeons and Dragons. The first thing you say is perfect, on point as well. Temporal plot holes. Yeah. Why is the cat thing so cute? I know, right? Nice impression. I didn't give an impression in this video. I gave an impression. Oh wait, did I do the? This is where I gave a good impression. This is true. So thank you for that comment. I like that comment. Thank you. Hope it was good. Yes. Ha 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 ha. I was on the floor laughing when this happened. It was funny. And I think we're at the comments that I've already responded to in a video. So these are all the comments. I had to rant because people don't understand it's not a cloud. Listen, when you oversimplify and just say clouds, you're just not understanding how it forms in the first place. And you're probably the type of person who thinks that space-time curves. It doesn't. I don't care how much flack I get for saying that. It doesn't curve like that. It's not space-time that curves. Anyway, thank you for all the comments. What the hell's with the Rasputin thing? I don't really care. I don't know what these are. Are these like... Are these like AI generated things that I should respond saying? I think he means it in a more general sense than the specific definition of what an electron does. What the fuck? Why did he say that? That was my point. But I'm sorry, I don't want your assistance making a response. I type it myself. I have a brain. Yeah, until observed. Shut up. Oh my god. The fucking observant thing. You realize in order to do any observing, quote unquote, you're using a photon beam or some kind of EM beam that's manipulating and totally erasing the electromagnetic field interference pattern because it directly is pushing all of that electromagnetic field, so it doesn't have the ability to make the interference pattern continue. That force is no longer present because the interference pattern is made by force of waves, and they're just simply dissipated and deleted. So the electron itself if you were to put it through another slit, for example, would then change its direction again. They are not orbiting. No. The orbital diagram is antiquated. It has been known to be wrong for some time. It is maybe simplifying, but again, no. I'm not just saying no because you're not saying the opinion that I have. I'm saying no because you're wrong. And there's extreme basic reasons why I know that you're wrong. The speed of the electron, the size of its orbit, the way that, or the size of its motion around an electron, around an atom. Not that we just don't know. Like, come on. The actual... Seriously, though. I don't care that people are so used to what everyone else is saying is what science is because it's been well understood, well established, it's everywhere, and for people to listen to someone else who actually just looked at the map and said, hey, you know what, it's actually this. Not just because of the math, not just because of the basic idea of conservation of momentum, it's silly. It's just silly. Thank you for all the comments. I'll see you in the next one. Toodles.